So now we are gonna learn the numerical based on Simpson's 1/3 rule. So here we will evaluate the definite integral by using Simpson's 1/3 rule. So let's see. And for that I have a numerical for you. So here we have to find out the value of definite integral from 0 to 1, and the function is x square upon 1 plus x cube dx, and we have to get the value of this integral by using Simpson's 1/3 rule. Now guys, we know the formula of Simpson's 1/3 rule. Now by using that formula of Simpson's 1/3 rule, we are gonna get the value of the integration. Now before that, if we want to apply the formula of Simpson's 1/3 rule, then we must get a table which has the value of the given function at different subintervals. Now here we have the extreme values or extreme points of the curve, that is 0 and 1. Now we have to take certain subintervals to get the value of this function. So guys, let's start. So here I'll say let's take value of x. So the first value of x is 0, and similarly we'll get the last value as 1, and for that corresponding value of x we are gonna find out the value of y. Now value of y is nothing but the value of the function f of x, so that would be called as y. So now I have to consider the subintervals. Now guys, since I am using the Simpson's 1/3 rule, it has one condition, and that condition is the number of subintervals must be even. So whatever subintervals I am going to consider over here, it must be even. So guys, what we'll do is between 0 to 1, I am going to consider the 4 subintervals. Now 4 is the even number, or I can take the 6 subintervals, or I may take the 10 subintervals or 8 subintervals. Now if I want to take the 4 subintervals, how would I take? So for that, we will take the difference between any two subintervals as 0.25. So by doing that, here we will get 0.25, then 0.50, then 0.75, and the last value would be 1. Now see here the subintervals are even. So we have 4 subintervals. So guys, always remember that you have to consider value of x in such a way that number of subintervals are even in case of Simpson's 1/3 rule. And also the difference between any two subintervals must be constant, because that difference is called as h. So here I can say that h is 0.25. Now few people must be thinking that can we take 0.2, 0.4, 0.6, 0.8 and 1. So guys, if you'll do that, so see here we have first value as 0. When you'll take 0.2, that will be the first subinterval, 0.4 second, 0.6 third, 0.4, 0.8 would be the fourth, and when you'll take 1 as the last value, that will become the fifth subinterval. It means guys, there we are getting 5 subintervals, which is an odd number which is not accepted in Simpson's 1/3 rule. So you cannot take the difference of 0.2 in between the values. Oh, okay, you can check it with 0.1. So by taking difference of 0.1, you can get the even subintervals. So here I've considered the value as, or value of h as 0.25, and I got the even subintervals. Now for each and every value of x, I am gonna find out the value of f of x, which is nothing but the value of y. So let's put all the values. So when I'll put 0 over here, we'll get 0 upon 1, that is 0. Next we'll put 0.25. So take your calculators and enter 0.25 whole square upon 1 plus 0.25 cube, and tell me the value. So here you'll get the value as 0.06153. Guys, you can check your values as well. Now I'm gonna repeat the operation for these 3 values. So just put these values in this function and get the value of y. So that will be So here we got these values. So here we prepared the table for Simpson's 1/3 rule, and now we'll give the names to the ordinates. So this value will be y0, this will be y1, y2, y3 and y4. So we're getting the last value as even. So let's start, or let's find out the value of integral. So what is the Simpson's 1/3 rule? So here I'll write by Simpson's 1/3 rule, we'll get the value of integral I as h upon 3 into x plus 2 times e plus 4 times o. Now this is the formula of Simpson's 1/3 rule. Now the value of h, we all know that it is the difference between any two values of x, or difference between the subinterval, which is 0.25 here we have considered. So here I'll say it is 0.25 upon 3. X is the sum of extreme ordinates, E is the sum of even ordinates, and O is the sum of odd ordinates. So let's find out these values. So here I'll say therefore x is equal to sum of extreme ordinates. So extreme ordinates are 0 and 0.5. So that will be 0 plus 0.5, and that is 0.5. Next, E, it is sum of even ordinates. Now guys, I've already calculated, or I've already considered this y0 and y4. So in remaining 3 ordinates, the even one is y2. So here we'll take, which is 0.22222, and O will be the sum of odd ordinates, that is the sum of y1 and y3. So here I'll write now let's take out your calculator and find out the sum of y1 and y3. So we'll get sum as so after getting all these values of x, e and o, we'll put these values in formula. So now here we'll get x, that is 0.5 plus 2 times e. So the value of e is 0.22222 plus 4 times o, which is 0.45713. So guys, here we have substituted all the values in integration. Now let's put this expression in the calculator to get the value of integration. So here by putting all these values in calculator, we'll get the answer as 0.23108. So this is the value of integration by using the Simpson's 1/3 rule. So guys, I'm sure that you like this video and you want to learn more concepts of engineering mathematics. So do log into ekeeda.com today itself, where you will get all videos of engineering at one place. So thank you very much. Keep learning.